Okay, so we're going to get started and we're beginning Unit 5. So Unit 5 is all about trigonometry. And that word should seem familiar because you did a bunch of trigonometry in grade 10. So we're going to start with a quick review, and then we're just going to add on a few things. So the lessons for today are very similar concepts to what you did in grade 10. We're just going to add in a few extra pieces. So to start, let's go over our rules and the tools you were given in grade 10. So the first thing that you did were the primary trigonometric ratios, or SOHCAHTOA. So the first thing that you would do is you'll label your triangle, and then you'll figure out which of these ratios to use based off what information you have. So that's the first one, and we will do another example of that to refresh your memory. Then we have the Pythagorean theorem. So remember that the primary trig ratios and the Pythagorean theorem can only be used on right-angled triangles, nothing else. If you try to use them on a non-right-angled triangle, you will get the wrong answer. It doesn't work like that. So we have our Pythagorean theorem, which you have used for years and years and years. We also have our sum of interior angles of a triangle. So remember that all of my angles on the inside equal 180 degrees. So if I have two of them, I can always find the third one. Finally, a couple more pieces of important reminders. First is the angle of elevation. Sometimes you'll hear it called the angle of inclination, especially if you're Googling resources or watching a video made by somebody else. But basically what my angle of elevation is if you are looking up at something, for example, to the top of a building, the angle of elevation is how far your chin moves to look at the top of that building. So picture yourself looking absolutely straight, and then you look up at the building. Think of how far your chin moved to look up. That is your angle of elevation right here. Next is your angle of depression. So let's say you're up here standing on a building or a bridge, and there's like a little flower down here, something like that. The angle of depression is how far your chin moves down to look at that little flower. So picture yourself looking straight, and then you move your chin down to look at the flower. How far you moved your chin is our angle of depression. So that's the best way to think of it. Actually think of you looking straight at something and either moving your head up and calculating that angle, or moving your head down and calculating that angle. Remember that they're both always measured from this horizontal. So sometimes if you don't have the exact angle you're looking for, we're going to have to do a little bit of work to find it. So I'll show you what I mean by that in a moment as well. Now the last piece that we need to talk about is that unknown angles are often represented with Greek letters. And I don't know why that is the case. They just always are Greek letters. So very often you'll see a theta, an alpha, beta, something like that. Just do your best to draw those Greek letters. They're kind of hard to draw. So that's what those are if you see them running through. Some people may have used them before. Some people may have just used a capital X, something like that. We do want to get in the habit of using Greek letters, because if you continue math in grade 12, post-secondary, you'll see a lot of Greek letters. Okay, let's do a couple of review examples. So the first one here, we're going to find the side or indicated angle. So for our first one, we're looking for side X right here. So the first thing I always do is I notice that it's a right angled triangle. So that means I can use SOHCAHTOA. Next, I circle the angle that I'm given, and I label the sides that have values. So the side that is across from my right angle is my hypotenuse, and the side that is touching my angle is my adjacent side. So now what I do is I look at my primary trig ratios and I see which one do I have enough information for. And if I go and look at them, the only one that uses A and H is cosine. So I'm going to have to use cosine. So I'm just going to write out the full formula. And again, I'm using cosine because I have adjacent and hypotenuse. And now I just fill in my values. So the angle we circled was 67. My adjacent is what we're looking for, and H is 18. Now our goal is to get X all by itself. So 18 is currently being divided. So we need to multiply both sides by 18. So we'll have 18 cosine of 67 is X. So let's put that into our calculator, which is 7.03 millimeters equals X. Now, if you did not get that answer when you typed it into your calculator could be on a wrong setting. So if that happens, just let me know and we can address it on a case-by-case basis, because everybody's calculator is a little bit different into how to turn that setting off. So if you have any issues at all and I'm doing all this math and you're getting different answers than me, please just give me a heads up so I can fix your calculator for you. Okay, so that's our first example. Let's try another one. So for this one, I'm really sorry the theta disappeared on me. So we're just going to put it back right here is where it lives. So that is the angle we're looking for. So the first thing I do is I notice that this is a right angled triangle. So it means that I can use SOHCAHTOA. So I circle the angle that I'm looking for. And now I label the sides that have values. So the side that is across from my right angle is my hypotenuse. And the side that is right across from my circled angle is my opposite side. So now I look and I see that I have O and H. So if I go to the top, the only ratio that has O and H together is sine. So I know that I'm going to do sine theta equals opposite over hypotenuse, like this. And now I'm just going to fill in my values. So we are looking for theta. Opposite is 11, 12 is my hypotenuse. And now I just want theta. I don't want sine of theta, I just want theta. So what we're going to do is we're going to have to undo the sine. So we get sine inverse of 11 over 12. And now that we've done unit 1, you might see sine inverse in a bit of a different way. In grade 10, you kind of just blindly wrote this little -1, not totally understanding what it was doing. But now we know that that little -1 undoes the sine function. So instead of having sine theta, I'll just have normal theta. So now I just sub that whole thing into my calculator. I would suggest keeping the fractions and putting those directly into your calculator, just because it eliminates any rounding error. So it's just a good idea. And we'll have 66 degrees. So that's my final answer. Again, if you are not getting the correct values, please let me know so we can fix your calculator. Are there any questions before we move on to our next piece? No? So far, so good? Okay, hopefully that's okay as review, so hopefully we remember how to do it. So in general with trig stuff, that's a great question. So the question that was asked was, how many decimal places should I round to? Typically for an angle, we round to whole numbers. And then for my side lengths, usually I round to 1 to 2 decimal places. If I'm going to be picky about it and it's going to be something where you could lose a mark or something like that, I'll make sure to put it in the question so it's very clear. But that's typical. Okay, so now is where we learn something new. Now we're going to learn what are called our reciprocal trigonometric ratios. And just like we have 3 primary trigonometric ratios, there are also 3 reciprocal trigonometric ratios. And they are cosecant, which is represented by CSC, secant, which is represented by SEC, and cotangent, which is represented by COT. Now, the reciprocal trigonometric ratios are defined as 1 divided by each of our primary trigonometric ratios. So basically, they're the exact same as the SOHCAHTOA you've known before, but everything is just under 1. So first, we'll start with cosecant. You guys might have an extra one of these here. Sorry, I don't know why sometimes it does that when I move over Google Docs onto my Mac, so I'm really sorry about that. You can just kind of cross it out. It should look like this. So the first reciprocal ratio that we're going to learn is cosecant, and cosecant is equivalent to 1 over sine theta, like this. And because sine theta is opposite over hypotenuse, my cosecant is going to be hypotenuse over opposite. So I can actually just flip my fraction of how I find cosecant. So for example, if I wanted to find cosecant of 20, how I would do that is I would do 1 divided by sine 20. So in my calculator, I'm just literally going to write 1 divided by sine 20, and I got 2.92. So just make sure as we go through this that you double check that you're getting the right answers, just to make sure your calculator is not on any funky settings. Okay, let's look at the next one. So my next one is secant, and secant is equivalent to 1 over cosine of theta. So if I were to write that as a fraction, all I would do is flip my cosine fraction, like that. And now let's do another example. So secant of 20 is equal to 1 over cosine of 20. 1 divided by cosine of 20 is going to give me 1.06. Like that. Now for cotangent. So cotangent, or COT, is equal to 1 over tan theta. So similarly, I think of my tan ratio, which is opposite over adjacent, but I'm going to flip that to get adjacent over opposite. Like that. And now let's try an example. So cotangent 20 is equal to 1 divided by tan 20. And that will equal 2.75. Any questions so far about these? The thing I think is hardest is that the one that has to do with sine starts with C, and the one that starts with S goes with cosine. I find that the hardest part, but in general, it's pretty straightforward if you were comfortable with SOHCAHTOA before. Okay, I don't see any questions coming in, so let's move on to a few examples. So for this first example, for the triangle below, we're going to calculate all 6 trigonometric ratios, and then we'll use one of them to determine angle A. So the first thing we're going to do is label our triangle. So I notice that it's right, so it means I can use SOHCAHTOA. So I'm going to circle the angle I'm looking for, and label my triangle. So the side across from the right angle is my hypotenuse. The side that is touching my angle is my adjacent, and the side that is across from my angle is my opposite side. So now that I have that, I'm just going to start working through all of my ratios. So the first one is sine of A. It's going to be opposite over hypotenuse, which is 9 over 15. Then we have our cosine of A, which is equal to adjacent over hypotenuse, and that is equal to 12 over 15. Then we have our tangent of A, which is equal to opposite over adjacent, so 9 over 12. Now we found our primary trigonometric ratios, but we also need to find our inverse ratios. So cosecant of A is going to equal the opposite of my sine. So take that fraction and we're just going to flip it. So now that will give me 15 over 9, like that. Next, we'll find secant of A is equal to h over A, which is 15 over 12. And then we have cotangent of A is equal to adjacent over opposite, so equal to 12 over 9. Now the last piece of the question is to determine angle A to the nearest degree. I'm just going to use tan because it has the most space under it. So I have tan A equals 9 over 12. So 9 over 12 represents tan A, but I just want plane A. So to do that, we have to undo the tan. So tan inverse 9 over 12. And we will get 36.9 or 37 degrees. And that is our final answer. So the whole thing isn't too crazy challenging, but there are a few pieces that make it kind of hard to remember everything. Okay, we have a lot of examples to go through, so let's do another one. So the next one here says that a camera is mounted atop of a roof of an apartment building and is 20 meters above the ground. It looks down at a car with an angle of depression of 68 degrees. How far away from the building is the car? Calculate the distance by using two different methods. So anytime you have a word problem with trig, I would highly recommend you start with a diagram. So that's what I'm going to do. So here's my building, like that. The building is 20 meters high. I have this little camera thing on top of the building here, and it sees a car down here. So our camera is looking down at the car, and it's looking down at the car at an angle of elevation of 68 degrees. Sorry, an angle of depression of 68 degrees. So we always remember that our angle of depression is measured from the horizontal. So this here will be 68 degrees. So what we're looking for is this length here. How far away is my building from my car? Now we also have that same length in another spot. That same length is also up here. So let's try to set this up into two different triangles because we need two different methods. So the first thing I'm going to do is I'm going to outline my first triangle. So here's my first triangle. And it is a nice right angle triangle like that. And the only other piece we need to figure out is this angle up here. So I know that from here to here is 90 degrees, and this much of it has been used up by 68. So I need to find the remainder. So I'm going to do 90 minus 68. And that equals 22. So 22 goes in here. So there's my green triangle. Now the question asks me to solve this two ways. So I need to find a second triangle. So if I look here, I do have a second one. So I have my distance to the car on the ground, but I also have my distance to the car up here. In addition, I have the height of my building on the green side, but over here, that height would still be the same. So now let's separate those triangles and solve for x. Now we're just going to do this two different ways just because that's what the question said. So it wants us to kind of get creative and know that there's different ways to do stuff. So here are my two triangles. For the first one, we have 20 meters, x, and 22. So first thing we do is we notice that's a right angle triangle. So we know that SOHCAHTOA is okay. Then I circle my angle and label the sides that have stuff on them. So the side touching my angle is my adjacent, and the side right across from my angle is my opposite. So I have O and A, so that means I'm going to be using tan 22 equals x over 20. And then to get x all by itself, I'm going to times 20 times 20. So I'll have 20 tan 22 equals x. And we will get 8.1 meters equals x. So that's our first one there. Let's try the same question using the pink triangle. So the pink triangle has 68 there, 20 meters here, and x. So the first thing I take note of is that it is a right angle triangle, so I can use SOHCAHTOA. Then I circle my angle, label my hypotenuse right across. I guess I don't need to label my hypotenuse because there's nothing on it, but you can if you want. The side touching it is my adjacent, and the side directly across from it is my opposite. And now I have O and A, which means I'm going to use tan again. Opposite over adjacent. So now I need to get that x off the bottom. So I'm just going to multiply both sides by x. Of x tan 68 equals 20. And then to get that x all by itself, I need to divide both sides by tan 68. And I'm left with 8.1 meters. So no matter how you approach this question, you will get the same answer. So if I only asked you to do it one way and you chose one of those, you would be good to go. Any questions so far before we move on? We have one more example from this, and then we're going to move on to one other new thing. Okay, no questions so far. Hopefully this is coming back from grade 10, and that's why we don't have any questions. So our last one here says, given a right triangle with acute angle theta, if tan theta and cotangent theta are equal, describe what this triangle would look like. So I'm sorry that for some reason I have tan and cotangent written twice. I don't know why they do that, but what can you do? It's happened on past notes, and I don't know, kind of makes a bit of a mess. Oh, yeah. I don't know why it does that. Sometimes it just does it when I move my stuff over because I'm on a Mac. I don't really know, but there should only be one. Um, Sorry about that. Okay, so given a right angle triangle with acute angle theta, um, if tan theta is equal to cotangent theta, describe what kind of triangle this is. So let's start by drawing a diagram. So we know it's a right angle triangle. And we know that we have an acute angle theta. So I'm just going to start by labeling my sides with A, B, and C. And it doesn't matter what letters you use. I'm just using these letters because we usually use them in the Pythagorean theorem. So they'll be nice and familiar for you. So now let's figure out what tan theta and cotangent theta are equal to. So tan theta, I'm going to start by circling my angle and labeling my sides. So the side across from the right angle is my hypotenuse. The side touching my angle is my adjacent. And the side across from my angle is my opposite. So now we'll have tan theta is opposite over adjacent. So tan theta is equal to B over A. And then for cotangent theta, I'm going to have adjacent over opposite. So cotangent theta is equal to A over B, like that. So now, how can I make this equal to this? What has to be true? So what I've learned here is that these two have to match to make this equal, and those two will have to match. So basically, for this to happen, A has to equal B. It's the only possible option. So if A and B are the same values, I could say this triangle would be isosceles. Now I need to try to spell that. Isosceles. There we go. Any questions about that so far? We're okay? So how I got it was I need this to be equal to this. So the only way that that could be true is if A and B were the same things. That's the only way I could have A over B equaling B over A. That. So I could even go, I guess you could try to isolate it, but even just from here, for these two expressions to be equal, this has to equal that. There's no like algebraic way I found that out that you missed or anything. Okay, any other questions before we move on to lesson 5.2? We're okay? All right, let's move on. So our next lesson is special triangles, and these two are connected because they actually make a lot of sense together. So let's start with a little bit of a warm-up or practice. So a 4-meter ladder rests against a wall such that the angle of elevation of the ladder is 45 degrees. How far up the wall exactly does the ladder reach? So let's start by drawing a diagram. There's my wall, and there's my floor. And I'm going to lean a ladder up against it, like this. There we go. It's beautiful. And now I'm going to fill in my values. So I know that it makes an angle of elevation of 45. So that angle would go here. And I know that the ladder is 4 meters tall. So I can do that. And I'm looking for how far up the wall my ladder goes. So we can just put in an X for that because that's what we're looking for. Now, we first notice that it's a right angle triangle because of that wall and the floor. And so I can use SOHCAHTOA. So now I'm just going to circle my given angle and label the sides that have stuff on them. So across from the right angle is my hypotenuse, and across from my angle is my opposite side. So the only ratio that uses opposite and hypotenuse is sine. So we'll have sine 45 equals opposite over hypotenuse. And our hypotenuse is 4. So now I'm just going to multiply both sides by 4. I will get 2.828. There we go. Any questions so far? Hopefully that one is pretty straightforward. Okay, so now our calculators give us approximations for unknown sides and angles using trig ratios. So when I say approximations, I mean a decimal. So when I get this answer, I'm getting a decimal here. But we are able to find exact values for sine, cosine, sine, cosine, and tangent for specific angles. So the goal here is to do our best to avoid rounding, because when we round, we are making things inaccurate. So if you're going to be using trigonometry to build something or engineer something, we can't be rounding too much or else our final answers are going to be off. So that's why we like to use exact answers whenever possible. So how we get these specific angles and these exact values are from special triangles. So we're going to go through and explain what special triangles are, how you can find them, all of that stuff. So let's start by considering a right isosceles triangle where the two equal sides have a length of 1 unit. So here's our isosceles triangle here. We have a right triangle. You can see it has a right angle and both sides are 1. So that's our first start. So since it's an isosceles triangle and has two equal angles, the angles must be 45 degrees. And the reason why these two things have to be 45 is because in an isosceles triangle, because these side lengths are the same, those two angles have to be the same. There's no situation in which they won't be if these two sides are the same. So if I have 180 degrees in my triangle and I've used up 90 here, the other 90 has to get split evenly between these two. So that is how our isosceles right triangles work. Now, what we want to think about first is how can we find the hypotenuse? So I want to find the length of this side over here. So I have a right angle triangle and two side lengths. So I can use Pythagorean theorem. So we'll have a squared plus b squared equals c squared. I'll have 1 squared plus 1 squared equals c squared, like that. So we'll have 1 plus 1 equals 2. So that means that c is root 2. So I know that when you square root like that, you should have a plus or minus. The reason why we don't include it here is we're talking about side lengths. So you can't have a negative side length. So that's why we don't need to worry about the negative sign. Okay, so the resulting triangle can be used to determine the exact values for ratios involving 45 degrees. So anytime we have a ratio that involves 45 degrees, we can use this special triangle that we just put together. So we have 1, 1, and root 2. This is our first special triangle, and I'll show you how to use them. I'll show you what that means, how to use them. So I'm going to look at the pink triangle, and I want to, oh, yes, Ethan, you can type your question. I'm just going to draw our special triangle again down here so I can have this bigger for you. Oh, your calculator just puts into exact values. That's a good question, actually. A lot of people's calculators do that. And if we were not learning online, I would make you do the quiz on this without a calculator. And if you're planning on taking 12U functions, they will also make you do it without a calculator. So you really do need to be familiar with the special triangles. You will be able to right now check it on your calculator, so that's beneficial. But long term, you need to know these because in grade 12, they'll say, okay, this test is no calculators, nothing, you just got to know it. But like, there's no way we can do that online. Does that make sense? Hopefully it does, yeah. Okay, so we're going to now state exact values for all of these. So the first one is sine of 45. So what we're going to do is we're going to start by circling one of our 45-degree angles, and it doesn't matter which one. And then I'm going to label my triangle. So here's my hypotenuse, here's my adjacent side, and here's my opposite side. So now let's find sine 45. So remember, sine is opposite over hypotenuse. So here our opposite side is going to be 1 over root 2, like this. Now, one thing that is really important is we don't like having radicals on the bottom. Remember that? So the other way to write this and how you'll commonly see it written is we'll multiply both the numerator and the denominator by root 2. So we'll have root 2 over 2. So depending on the text you're looking at, sometimes you'll see it like this, and sometimes you'll see it like this. These two things are the exact same thing. They just are basically in different forms. So because we don't like having radicals on the bottom, this is my preference here. But if you're online, you might find this if you're looking at other resources. Okay, so now let's calculate cosine of 45. So cosine is adjacent over hypotenuse. So again, we have 1 over root 2, but we don't like to have that radical on the bottom. So I'm going to multiply the numerator and the denominator by root 2. So I'll get root 2 over 2. That's my second one. Now for tan 45, if I look at my special triangle here, tan is opposite over adjacent. So I have 1 over 1, which just equals 1. Now let's do our inverse ones that we just learned about. So cosecant is hypotenuse over opposite. Remember, it's just the flipped version of sine. So that will be root 2 over 1. So that one just equals root 2. Now secant 45 is hypotenuse over adjacent. So we'll have root 2 over 1, which is just root 2. And finally, cotangent, which is adjacent over opposite. We'll get 1 over 1 again, which is just 1. So these are your special triangle values. So again, just to make them nice and clear, sine 45 is root 2 over 2. Cos 45 is also root 2 over 2. Tan 45 is equal to 1. Cosecant 45 is equal to root 2. Secant 45 is root 2. And then cotangent 45 is 1. So you need to know these. So these are super important for you to know right here. And there's two things you can do. You can put those in your brain. I find remembering the special triangle easier, and even drawing the special triangle on the side of my page and then finding all of these, I find that easier. But you need to know these two things here. So whether you draw out the special triangle and find them yourself, or if you kind of have those in your brain, you need to know them, because I will start asking you for exact values of stuff when you see the angle 45. Okay, so that is our first special triangle. We do have another one. So here's our second special triangle that you need to know. And our second special triangle has a 30-degree angle down here and a 60 over here, and then a 90. So now this helps us to find values for 30 degrees and 60 degrees. So let's start by looking at the 30. So over here, just so I can have all of this on one page, I'm just going to redraw that triangle. So this is the other triangle that I would highly recommend that you have committed to memory and you know this triangle. Even if as soon as you get to a test or quiz, you have to draw out the triangle, it's a good idea to know it. Yes, Dimitri, you can type your question, or you can turn off your mic if you prefer. Oh, it's not a negatives. I can totally see why you thought that though. They're basically just saying like, it's 30, 60, 90. I think the idea was to be like an arrow, or just say like the 30, 60, 90 triangle. Like it was just how you're supposed to say it. I know it looks like negatives, but it's not. I totally see why you thought that though. Okay, so let's now label our triangle. So for this one, we're going to circle 30. So this is our hypotenuse here, our adjacent, and our opposite. So now using that, let's find all of these ratios. So sine is going to be opposite over hypotenuse. So it's going to be a half. Cosine is adjacent over hypotenuse. So we'll have root 3 over 2. Tan is opposite over adjacent. So I'll have 1 over root 3. Now again, we don't like to have radicals on the bottom. So I'm going to multiply the denominator and the numerator by root 3. So that will give me root 3 over 3, like that. And now let's do our other one. So our cosecant one is hypotenuse over opposite. So we'll have 2 over 1, which is just 2. Then our secant is hypotenuse over adjacent. So we'll have 2 over root 3, which is going to be, we can't have that radical on the bottom. So we'll have 2 root 3 over 3. And then cotangent 30 is going to be our adjacent over opposite. So we will just have root 3. So again, those are the magic values that you need to know. You can find them all from the triangle. So if you know that triangle, you can go through this process if you need to, but that is really what you need to know. So again, our magic numbers, our sine 30 is a half, cos 30 is root 3 over 2, tan 30 is root 3 over 3, cosecant 30 is 2, secant 30 is 2 root 3 over 3, and cotangent 30 is root 3. So those are the numbers that we really need to know. Any questions so far? So again, I would recommend just knowing these triangles backwards and forwards. That way you can figure these out if you had to, instead of memorizing all of the numbers. That's usually my suggestion, but it's up to you however your brain works. Yeah, Tirth, you can type your question, or you can turn off your mic and speak, whatever you prefer. Dimitri, you can also just type your question in. That way I can just address them both one after another. Sure, you can make a table for it. I find it easiest if I know the triangles. You can't, like on the quiz and on the assessment, you should not have that with you, because for grade 12, they're going to assume you know these. So when you get to grade 12 functions, they're going to just assume you know. Like if you remember it, absolutely. So if that is your strategy, you can do it. I would highly recommend that you know where they come from, that you know that they come from here to get this, just so that when you move on from this and you expand on it in grade 12, that you know where everything comes from. But if that's your process for right now, that's totally okay. Dimitri, so is there a specific reason why we need to know these rules? There is actually. So trig is one of those topics that has a ton of real world applications. So if anybody's thinking of going into anything in terms of engineering, architecture, a lot of types of design where you need trig, which there's actually so many things out there. You always need to know exact values, and that's because we don't want to round things. We want to limit our rounding as much as possible so that our numbers are exact. And then when you get to grade 12, they'll expand on this even further and have even more exact values. So it's actually very beneficial in life, future careers, things like that, to know these. So that's why we'll do some examples after, but knowing these special values is very, very important. Okay, so that is our exact values for 30. Let's do our exact values for 60, and then we'll do some examples. So I'm just going to draw the triangle again down here just so you can see it while I'm talking about it. Like that. This time, we're going to circle 60, and we're going to label our triangle around 60. So here's my hypotenuse. This is my adjacent side, and that's my opposite side. And now we're going to go through again and fill out all of these values. So sine 60 is going to be opposite over hypotenuse. So root 3 over 2, like that. Cosine of 60 is adjacent over hypotenuse. so 1/2. Tan 60 is opposite over adjacent, so we'll have root 3. And now we'll go to cosecant, which is going to be hypotenuse over opposite. Hypotenuse over opposite. And we don't like to have our radicals on the bottom. So we multiply that by root 3 and that by root 3. So we'll have 2 root 3 over 3. Secant 60 is going to be hypotenuse over adjacent, so just 2. And then cotangent 60 is going to be adjacent over opposite, so 1 over root 3. And we don't like to have a radical on the bottom, so we'll have root 3 over 3. So that is your last set of rules that we need to know. Again, all of this kind of depends on how your brain works, of how you want to remember this. Some people very much like to just remember the values because that's what works better in their brain. And that is okay. The way I like to do it, because I find that very difficult, is I prefer to remember the triangles. That way I can figure it out because that is easier for me to remember. So it's up to you how to remember it most. Dimitri, do we need to remember this in grade 11? So you will need to know this for next year. You will go over it. So depending on if you're taking grade 12 functions, whatever your plan is, if you're taking it next year, if you're taking it in 2 years, whatever your plan may be, you will need to know this stuff. Of course, they will review it because normal school doesn't go quite as fast as this is. But it's actually very, very important, and you will use this again. Okay, so here are all our values. We have them all ready to go. And now let's do some practice problems with them so you can see why we even use this stuff. Okay. Oh, my iPad's frozen for a second. Okay. So make sure that you know your special triangles. I think I've made that point super clear, but please make sure that you really do know these. Okay. So we're going to find the exact values of the following. So you have everything on your paper. Please make sure that, like, if you don't know these, that you go back and reference them. I've done this stuff a lot, so I know, kind of start to know them off the top of my head. But if you're confused at any point, please stop me. So all I'm going to do is I'm going to start by writing the exact values for all of these things here. So sine 45, if I don't know it, remember, this is your process. If you don't know what sine 45 is, you go up here and you look, okay? So sine 45 is root 2 over 2 from over there, and I'm just going to fill that in. Now I have cosine of 45, which is also root 2 over 2. And I'm going to add that to sine 30, which is 1/2. So now it's just a BEDMAS question. So I start with the multiplication, and I'm multiplying, I'm multiplying fractions. So I just multiply straight across. So root 2 times root 2 is 2 over 4 plus 1/2. And now I can simplify that 2 over 4, 1/2 plus 1/2, and that just equals 1. So any questions about where I got that? I know that this is a lot of fractions, so hopefully it's not too crazy. Okay, so that's our first example of how to use this, right? So now that I know these values, I don't have to plug that whole thing into my calculator. I can just do this all by hand really quick. So that's one of the bonuses of this. Now I'm going to try B. So B is sine 45 over cos 30. I'm just going to quickly write it like this because we're going to be dealing with fractions. So I think that that will make things easier for you. So sine 45, my magic number for that is root 2 over 2 divided by cos 30, which is root 3 over 2, like this. So remember, when we divide fractions, I flip the second one and multiply. So I flip the second one and change that to a multiplication sign, like that. So now that will give me 2 root 2 over 2 root 3. And we can get rid of those 2's there. Oops, oh, no, I didn't. Thought I made a mistake. All is good. So now we'll have root 2 over root 3, but we can't have a radical on the bottom, so we have to get rid of it. So we'll times root 3 times root 3, and that will give us root 6 over 3. Any questions so far? No, we're okay? Okay. We're almost done. Okay, let's try another example. So we're going to use the appropriate special triangle to find theta. So now we're going to do it backwards. The first thing I want to say is I don't know why we get this double sign here. I think it's just from me bringing these over on my Mac, so I'm sorry, I don't know why those are there. You can just cross it out or erase it. There we go. So now we're going to find theta. So sometimes you'll have to do this backwards. So when I go to find theta, I always use my inverse sine of root 3 over 2. Now you can do this on your calculator because we will all have calculators on our quiz and on our task, but you can also do it by hand. So if you start to remember all of your special triangle values, we should get to a point where we remember that root 3 over 2 is 1. And if I go and I look back through here, where's root 3 over 2? Oh, it's right here. So the angle must be 60. That is basically what we're doing here. If you put this in your calculator, though, you would end up getting the same answer. So it would end up working out. Okay, let's try another one because I think that these ones are a little trickier. For B, we have root 3 tan theta equals 1. So we have root 3 multiplied by tan theta equals 1. So what we're going to do is let's try to get tan theta all by itself to get started. So I'm going to divide by root 3 on this side, divide by root 3 on this side. So we'll have tan theta equals 1 over root 3. Now remember, we don't like having these radicals on the bottom, so let's get rid of that. So we'll have tan theta equals root 3 over 3. So now I'm going to go back through my special triangles to find where tan theta is root 3 over 3. And when you look back through all of your special triangles, we'll get that theta equals 30 degrees. That's our final answer. Okay, so let's do one last example and then we're done because I know that this has been really, really long. So our last example here, we're going to find the area of this triangle and the formatting went totally bonkers. So I'm just going to draw it down here for you. Sorry, I don't know. Sometimes with triangles, the formatting goes nuts. So this is what your triangle was supposed to look like. So we have an alpha here, a beta here, a right angle, 45 degrees here, and that's it. So what we are given right now is we're given that cosine of alpha is equal to root 3 over 2. So I don't know if that printed on there either, but there is our given, and what we're trying to do is we want to find the exact area of the triangle. Sorry about the formatting there, but at least now we all have the question because this is a really good one to go through together. Okay, so the first thing we're given is we're given that cosine of alpha is equal to root 3 over 2. So we know that if I circled alpha and labeled my triangle, so that's my hypotenuse, and that is my adjacent side, that we would get 3 over 2. So that is my adjacent, and that is my hypotenuse. So we can fill in those values there. There we go, a smaller eraser. So my adjacent is root 3, and over here must be 2. So that's the first thing that we figured out. And now if I know my special triangles, if I have root 3 and 2, and I go back up to the picture of my special triangles, this must be 1. So that is the first thing that we need to know. And now we're going to find the area of our first triangle because we have our base and our height. So area 1 is going to be base times height divided by 2, like this. So my base is 1, my height is root 3, all over 2. So we'll get root 3 over 2. Yes, Dustin, feel free to type your question. So because I have that, it's telling me the cosine is there. If I have 2 of the sides, the third one has to be 1. So because of the Pythagorean theorem, if I plugged like these 2 values into the Pythagorean theorem to get that other side, then it has to be 1. And the reason for that is because I have this right angle here. So because I know that ratio and I have this right angle, that third side has to be 1. So if you plugged it all into the Pythagorean theorem, like if I just gave you that and you couldn't remember your special triangle, you could even use the Pythagorean theorem to get there too, which would be really helpful. Okay, so now let's look at triangle 2. So because this angle is 90 and this is 45, if I use my interior angles of a triangle, beta also has to be 45 up here. So that means we do have another special triangle. But if you look here, this is already root 3. So it means it's just like my special triangle. It's just that these 2 sides have been multiplied by root 3. So we'll just have this side, oops, It was originally 1, but we multiply it by root 3. And then this one was originally 2, but we multiply it by root 3 to get root 6. Oh, okay, that's a good question, Dustin. So because, sorry, B3. I can look into that for you after. Because I guess it could. I mean, we're trying to use special triangles here, so this was kind of designed to use special triangles. But I can try, after we're done with this example, I can, because we've gone like over an hour, I will try to figure that one out for you, and we can go through it together after I finish this example and everyone goes to do homework, and then we can do that one together. So don't think I'm totally understanding what you're saying, so then we can do it after. Okay, so I've now labeled my second triangle, and just to be clear on how I got all of those, my special triangle looks like this: 45, 45, and 90, and it usually looks like this. But because this side was already root 3, all of these have been increased by root 3. So that is how I got the values up here. Just so everybody knows where those came from. So now let's find the area of that second triangle. So area 2 is base times height divided by 2. So our base is root 3. Our height is also root 3, all over 2. So root 3 times root 3 is going to give me 3 over 2, like this. And now we want our area total, which is A1 plus A2. So A1 was root 3 over 2 plus 3 over 2. So our total area is 3 plus root 3 all over 2. So that's our last example. This does get a little bit trickier, but that is it. So on the unit outline, there is a bunch of homework for you guys to do. And then for the rest of the afternoon, we will be doing just unit 4 review.